Hi, I'd like to talk to you a little bit about the system curve, what it is, how you use it, maybe how come you never heard anything about it, but let me introduce you to that idea. First, let's go to my website, www.pumpfundamentals.com. Go to the visual glossary, and then in the submenu here, find system curve. Here it is. Voila. So this is what a system curve looks like. I've got three plotted here on the same graph. So what we're looking at is the pump curve of a pump that we have selected or that's existing, in the field, and we're trying to find out what's going to happen, how this pump is going to operate as I change the flow rate or change some characteristic of the pump. So we're seeing here the flow on the x-axis and the head on the y-axis, and this diagram comes straight from the manufacturer, right? And what we see is the different impellers that are available for that model pump from 7.5 to 9.5. And we're seeing the efficiency curve. So this will tell us how efficient our pump is while it's operating. We're typically trying to get the pump to operate at its highest efficiency for a couple of reasons. One is that you're going to consume less power to do the job at that point, and the other reason is that the pump will just run a little bit better. It's more balanced. There'll be less vibration from the pump if it's running right at its best efficiency. So there'll be also less wear. So what do we see in these red curves? What we're showing is three possible operating points of the system. Now let's just take the middle one. How do we generate this curve? Well, what we do is we do our calculations on the system, and we figure out what the static head is and the friction head, and we know our flow rate. So that'll fix this point here. Right, so this is something that's around like 35 gallons a minute and close to 140 feet of head. So we're saying that we think the pump is going to operate at this point, or maybe it's a measurement we got from the field or whatever. But anyways, this is our first point on the curve. The other point you can see here, right here on the axis here, this is the static head right here. Because there's no flow, zero flow, the static head in this particular case is 100. Then we calculate how much friction head do I have to operate at 35? So that gives me the other little bit, and then I have that point A. How do I generate all these other points? Well, I just do all those calculations again at a different flow rate, and I'll be able to trace this curve right here. Now, let's say that what I'm traced now is a pump that's operating, and it's got let's say a discharge valve, maybe that's partially closed, let's say, and this is all incorporated in the values that I've either measured or calculated to get to this point. So what we're going to see is, let's say if I decide to close this valve further, what's going to happen? Well, by closing the valve, obviously I'm going to increase the friction, so I'm going to go up, right? I'm going to have higher friction, therefore I'm going to have a higher head. So keep in mind that this is a pump that can only operate on this curve. Now, once it's selected and running, these curves are no longer available, right? This would only be available if you were at the design stage and trying to figure out what impeller diameter you need. So as I close the valve, I have additional friction, the flow will drop. So you see I would go up on this curve here and wind up somewhere here with less flow, higher head. And the same thing would happen if I open the valve. Then I will have removed a lot of the friction, therefore the flow will increase. So I will need less head, but I'll have higher flow. So it's possible for me to move up and down this curve here by influencing what's available in the system, i.e., a valve that might be open or closed. If everything is open, if there are no valves that are closed, then I can't affect it one way or the other. But one effect would be, let's say, if I wanted to go further and I added more pipe, well, this would increase friction. This would have the same effect as going up on the curve, and flow would be reduced. If I didn't want flow to be reduced, well, here's the magic now of this curve. If I wanted um, to well, let's say that I wanted to have more flow out of the same system. How would I do that? Well, I would have to more flow out of the same system means I would go up on this system curve here, and this is the useful part of this curve. It would tell me that, listen, buddy, if you want more flow, you're going to have to get another impeller, right? And then with another impeller, you're going to get more flow. You might also need a bigger motor. So the range that's available to me on this pump is to follow the system curve all the way up till I get to the maximum impeller. It means I have to change the impeller, of course, so that's kind of awkward. What we often see nowadays is that the pumps are fitted with variable speed drives, so that you can actually change the speed of the pump at any time you wish, or even control it automatically. So these curves then, instead of having impeller diameters, they would look exactly the same, but these curves would all be different speeds. So this might be, I don't know, 800, 900 RPM, 1000 RPM, right? And then you would see that by increasing the speed, you would always be on the system curve, but if you increase the speed, let's say this was the 800 RPM, and this was the 900 RPM. If you increase the 900 RPM, you automatically ramp up on your system curve and meet the 900 RPM curve, and this is a way that you could get higher flow with the same system. So I don't know. I hope this helps. This talk about the system curve. The system curve is really a set of calculations. Most people only calculate 1 point because that's all they think they'll ever need. But if you're thinking that you're going to have to figure out what impeller you need for lower flow or higher flow, or what speed you're going to have to run under these different conditions, then you really need to figure out a system curve. So that's the story on the system curve. Think about it, and next time you do some calculations, just plot that on the manufacturer's curve, and this way, if anybody asks you what happens to this pump and this system if we're running at a lower flow, bang, bang, you got the answer. Okay, bye for now.
Right. This is not a science joke, but a Groucho Marx joke. Why don't we break away from all this and lodge with my fleas in the hills? Well, I mean, flee to my lodge in the hills.